we can solve simple series and parallel or bridge type of resistive networks using Kirchhoff's circuital law, mesh current analysis or nodal voltage analysis techniques. But in a balanced three-phase circuit, we can use different mathematical techniques to simplify the analysis of the circuit and thereby reduce to amount the maths involved, which is in itself a good thing. Standard three-phase circuits or network take on two major forms with the name that represents this way in which the resistance are connected, a star connected network which has the symbol of letter Y, we represents at WYE Y, or and the delta connected network which has the symbol of triangle and delta. If a three phase three wire supply or even a three phase load is connected in one type of configuration, it is can be easily transformed or changed into an equivalent configuration or other type of using either star delta transformation or delta star transformation. A resistive network consisting of three impedance can be connected together to form a T or configuration, or but the network can also be redrawn to form a star or Y type of network as shown below. So let's start our video right after this short break.
Audio Jungle. Audio Jungle.
Star connections is generally used in long distance transmission line as insulation requirement in less in star connection. And delta connections are generally used in distribution networks for short distance. Alternators and generators are usually star connected. If you consider this one, transformer windings which are also are connected in a star delta connection. So if you see, the star and delta connections are also used in starting of three-phase induction motors using the star delta starter. Delta star starters are installed in even cement industries for high inertial load applications. Power capacitors in three-phase capacitor bank connections are either delta conveyed connected or star connected. Now, the star delta connection is an arrangement of passive elements R, L, and C such that the formed shape resembles a star or a delta symbol. These connections are neither series nor parallel. Such connections are simplified using star to delta or delta to star conversion. Such connections are found in complex DC circuit, full bridge rectifier. Such connection has large applications in three-phase AC system. So let's begin how star delta works. Before this, let me start. What is a star network? A star network is rearrangement from T network. You see here there is a T network. So what we say here, that is R1, R2, R3. R1, R2, R3 is there. Here R1 is there. Here R2 is there. And here R3 is there. And this T-shaped network is there. This T-shaped network can be also represented in this manner also. And this is also called, you say this is a star. So, three end resistors are connected in Y or star fashion. A common node point of the star connection is known as neutral. This is called neutral point. Now, the three ways a star connection may appear in the circuit. How they appear? Like this, either Y shape or T shape or this star shape. These all shapes are here star shape. This is nodal point. This is another nodal point. This is your nodal point in terms of star. This can be represented like this, like this, like this. Whenever you find this type of three branches, then you can consider this as a star connection. Now, what is delta connection? When three resistors are connected in a fashion of form of closed mesh, delta means triangle. So connection formed is known as delta connection. Delta network is here like A, B, C. Triangle is there. Between AB, resistance RAB is there. Between BC, resistance RBC is there. Between CA, resistance RAC is there. Here, RAC is a resistance connected between A and C. So this is a delta connection. It means obviously from it's a as in triangle form. Now this triangle can be appear in circuit how many ways? Like this way. It may be triangle like this way. Maybe there is an inversion in the triangle, or maybe like this way. It won't seems like triangle, but here the pattern is in triangle format because the resistances are connected like this, like this, like this, and here the points end points are this point, and this point, and this also seems to be triangle. So in these three manners, if the circuit appears, if you find in circuit, then you have to consider this is a delta connection. Now let's start our star delta connection network. So delta network, consider the following delta network in the following figure. As far as you have seen how delta connections appears, so it is in the form of triangle. So let R1 be the resistance connected between A and C. Here R3 is the resistance connected between C and B. Here R2 is the resistance connected from B to A. So the following equation represents equivalent resistance between two terminals of delta networks when the third terminal is kept 1. So if you consider find the equivalent resistance between A and B, let's say we are interested to find A and B. So here when the current enters in from A node point, then it distributes in two segments, and R2, and here the same current will travel from R1 to R3 and then recollect on B point. So in this way we can say R1 and R3 are in series, and hence the series combination is parallel to R2. Finally, R2 is parallel to R1 plus R3. So R1 and R3 are series, so the resultant will be R1 plus R3, and here as it is in parallel to R2, so R1 plus R3 under bracket into R2 upon R1 plus R2 plus R3. This is the parallel connection. Similarly, go for BC also. What is BC? Between B and C, here we will find R1 and R2 are in series, and which is parallel to R3. Between here similarly RCA means the equivalent between A and C nodal points. So R2 plus R3 into R1 upon R1 plus R2 plus R3. Now similarly go for a star connection. The following figure shows the star connection network. As here you see this is a Y shape or a star shape. Here there is a star shape network corresponding to this above delta network. You say the point was same as in the delta network. The point was ABC. Here the point was ABC. Instead of this 3 points ABC, we have connected here a star network. This is point A, this is point B, this is point C, same. So as here the point was ABC, here also the point was ABC. Now this point is a neutral point, let's say capital N with another point, and here the connected resistances RA, RB, RC in these branches which are along with A, B, C respectively. So RA resistance at RA at the branch A, and RB resistance at the branch B, and the RC resistance at the branch C. So we say if you find here the equivalent, you have to find equivalent between A and B. Then how to find? Suppose the current appears here, and due to this open circuit here the current won't flow and current will continue to RB. So between A and B the resistance will be only RA plus RB. RC will not play the role as this is an open circuit between A and B. Similarly, if you go for B and C, then resistance equivalent resistance will be RB plus RC. You have to connect this two as in series, and here RA will not play in the role if you are evaluating this in B and C. Similarly, go for C and A. If you are evaluating between C and A, the resistance sum of resistance is RA plus RC. Now RB will not be considered as it is the part of open circuit. So here finally we get RAB is equal to RA plus RB, RBC is equal to RB plus RC, and RCA equal to RC plus RA. But RAB, what was there in delta? R1 plus R2, R1 plus R3, sorry, R1 plus R3 under bracket R2 upon R1 plus R2 plus R3, and so on. Now, so if you connect star and delta, as a star is here, the resistances of a star is like this, and the resistance of a star delta is in this manner. So if you equate it, then you will get the conversion of star network resistance in terms of delta resistance, delta network resistance. So what we say here, equating these equations. So if you equate it, then you will find RA plus RB equal to R1 plus R3 under bracket R2 upon R1 plus R2 plus R3. It's equations 1, and similarly you use for equation 2 and 3 also. So solving these three equations, how to solve? This is a special type equations. As in 6th class, 7th class level, you have studied how to solve the equations. So you just add these three equations, then you will get RA plus RB plus RC. All these terms are appearing twice. So what we say here, if you add this three equation twice of RA plus RB plus RC is equal to, you say here if you multiply R1 R2 and here R3 R2, here R1 R3 R3 R2. So in this way you will find R1 R2 R2 R3 and R3 R1 are also appearing twice here in this way. So we get twice of R1 R2 plus R2 R3 plus R3 R1 and R1 plus R2 plus R3. This denominator is throughout there. So finally what we say here, RA plus RB plus RC is equal to 2 disconnected, related. So finally equation 4 is R1 R2 plus R2 R3 plus R3 R1 upon R1 plus R2 plus R3. Subtracting the equation 2 from equation 4, then you will get the value of RA. Similarly here equation 2 was RB and RC. If you have to find RA, then you have to subtract equation 2 from 4. And if you have to find RB, then you have to subtract equation 3 from 4, and then you have to find RC, then you have to subtract equation 1 from 4. In this way, while subtracting one by one the equation, you will get the value of RA, that is RA equal to R1 R2 upon R1 plus R2 plus R3. And similarly, RB you can find R2 R3 upon R1 plus R2 plus R3, and also RC you can get R3 R1 upon R1 plus R2 plus R3. So in this way we can convert delta to star network. Now how to memorize this? So you can keep it in memory, as here this is a delta, you can see over there A, B, C, and in the same point we have connected here this is star. So how to connect this delta and star? Suppose let's say between A and C, that is RCA, and as here that was R1 R2 R3, so we have used RCA, RBC and RAB. So what we say here, that is an RA RB RC means any arm of a star connection is equal to product of two adjacent arms of delta upon or divided by sum of arms of delta. So in this way you can remember this all three relations. Means RA is equal to R1 R2 upon R1 plus R2. You have to divide with sum of all the resistance, and you have to multiply the product of resistance connected with A point, means arms passing through, adjacent arms passing through A. You see here from A the adjacent arms are R1 and R2. Let's see from A, it's passing R1 and R2 delta. So you have to multiply this R1, R2 and divide with R1 plus R2. So this will be the result. And if you have to find RB, RB means connected with point B, then you have to multiply R2, R3 and then divide with R1 plus R2, R3. Similarly, from C, so that is R1 from C, it is passing here, that is R1, R3. So you have to multiply with R1, R3 and divide with R1 plus R2 plus R3. See here, you can see RC. RC is equal to R1, R3 upon R1 plus R2 plus R3. Okay, anyhow. So in this way, you can keep it in memory. So easy way to remember delta to star transformation is any arm of a star connection is equal to product of two adjacent arms of delta divided by sum of arms of delta. So as in the previous chapter, we have discussed conversion of delta network into equivalent star network. Now let's discuss the conversion of a star network into equivalent delta network. The conversion is called the star to delta. As we have discussed from delta to star, now we have to go for star to delta. Let's see. RA equal to, once again the same equation, that is R1 R2 R upon R1 plus R2 plus R3, as we have discussed far. And now as far we have discussed RB and RC, we have already learned how to evaluate RA RB by making the product of adjacent arms and dividing sum of arms of delta. So in this way we can say RA equal to R1 R2 upon R1 plus R2 plus R3, RB also and RC. Now if you see here, and means delta network resistance in terms of a star network resistance. So let's manipulate the above equations in order to resistance of delta network in terms of resistance of star network. Multiply each set of two equivalents and then add, right? So RA RB plus RB RC plus RC RA. You have to multiply this one by one. Means RA into RB. Here first you use RA into RB and then RB RC and then RC RA and then add this. Then what do you get here? You will get here when you multiplying with RA RB, then you see here R2 is common, so R2 square is there and R1 R3. So R1 into R3 into R2 square. Here what is common? RB RC, that is here R3 is common. So R3 square you have to make and R1 R2, and in this way we will get on adding R1 R2 square R3, R2 R3 square into R1, R1 R3 R1 square into R2, and divided by R1 plus R2 plus R3 whole square. Now you can take out common over here. You say R1 R2 R3 are common in each and every term, so that R1 R2 R3 under bracket R1 plus R2 plus R3, and here also in denominator that is a whole square, so one of them term is related, and hence we find R1 R2 R3 upon R1 plus R2 plus R3. So RA RB plus RB RC plus RC RA, you will get R1 R2 R3 upon R1 plus R2 plus R3. Let's say this is equation number 4 for this segment. So by dividing equation 4 with equation 2, we will get here. You see, this is equation 2. So if you are dividing this one 4 from equation 2, then you will get RA RB plus RB RC plus RC RA upon RB is equal to R1. Now you can find R1 over here. Dividing this one, you will get RC. So RC will left over here in from second term, and in the first and third term, and this one here also RB is there in first term. So if you divide this here, RA will be left. So RC RA two terms will left, and here it's not leaving as RB is not appear over here. So R1 equal to RC plus RA upon RC RA upon RB. Similarly, another terms also you can go ahead RA. So by dividing equation 4 in equation 2, delta network resistance in terms of star network resistance. So multiplying each set of the two equations and then add, you will find in this way. So R1, R2, R3, you can evaluate this. So that is what we say here. R1 we have already evaluated. Let's see. R1 equal to RC plus RA upon plus RC into RA upon RB. R2 equal to RA plus RB plus RA RB upon RC. R3 equal to RB plus RC plus RB RC upon RA. How to memorize it? So easy way to remember the star to delta transformation is resistance between two terminals of delta. So you see here resistance between two terminals of delta, how to find, as here sum of the star resistance connected to those terminals plus product of the sum of the two resistances divided by the third. You see here, means we are saying the sum of the two resistances like R1 equal to RC plus RA and plus the product of this two and divided by this one third one. So how to find this? Suppose we have to find R1. Let's say this is R1. So R1 how to find? In this you have to multiply with this RA into RC and then means RA plus RC and then make a product of RA RC and then you have to divide with third one RB like this. Let's see here. R1 is connected between A and B. Let's see how R1 is connected between A and B. You have to come in this here. That is the delta connections. Let's see, connection is somewhere here. Means R1. Yes, R1 is here, and star connection, that is A and C. So R is R1 is equal to RAC, and then you have to divide with RB. So what do you say here? R1 that is, let's see, R1 equal to RC plus RA plus RC RA upon RB. So in this way we can evaluate this R1. So let's see to test how to star and delta transformations, whether you all got or not. So let's have a question. If a star network has all resistance equal to capital R, its equivalent delta has all resistance is equal to question mark. And another for delta to star, if a delta network has all resistance equal to R, its equivalent star has all resistance equal to. Think about, you pause this video and think about the result, then we will consider that you learned about how delta is conversing with a star and how a star is conversing with delta. So let's see. So okay, now come back to the video. If a star network has all resistance equal to R, its equivalent delta has all resistances equal to. The answer is 3R. Is it correct? And if delta has all resistance equal to capital R, its equivalent star has all resistance equal to R by 3. So to understand this all, let's start some problem and how to calculate this. So we'll practice one of them only as a star to delta conversion. So in a star, suppose resistance RA is given 6 ohm, resistance RC is given 3 ohm, and resistance RB is given 18 ohm. So just for practice, we have to find the delta values R1, R2 and R3. So let's start. Try yourself first and then see the solution. As we have already discussed that R1 which is connected between A and B, so how to find this? We have to make the practice with the formula, this one. So you have to make a product of RA and RC or add to RARC. No, first of all, as here there is a star to delta conversion, so second one was there. We have to add RA, RC and then make the product of RARC and divide it with RB. So in this way you will get the result. Let's see. So R1 equal to RC plus RA plus RC RA upon RB. This formula you have to use. So 6, and this type of calculation after more and more practice you have to calculate in only in your mind, as like this one. RA is 6, RC is here 3, so 6 plus 3 9 and multiply 6 3 18, 18 by 18 1, so 1, and here that is that, what was that, 6 and 3, so that is R1 is 10, and similarly R2 R3 you can evaluate. So let's see, R1 is equal to 10 ohm, R2 similarly you will get 60 and R3 you will get 30 ohm, and this way you can convert this. Now how to applicate this in circuits? So we will go in this same video, we'll go for circuits and complex circuits, those circuits in which we can't easily handle as with the help of series and parallel. So we will if you have to solve this without using this star delta, then you have to go in Kirchhoff's second law, loop law, and that will be very tedious and cumbersome work. So to avoid this tedious work, we will use a star delta conversion. By the help of a star delta conversion, we will immediately convert the circuits in series and parallel order, and will safely uh, conclude and evaluate the equivalent resistance. Let's see. So we'll take an example here as find the equivalent resistance between A and B in the given circuit. Look, this is the point A and this is point B. From this arm, that is 4 ohm connected, and here the pattern is seems like Wheatstone bridge. So you see, is this a Wheatstone bridge? As this is 4, 8, and this is 8 and 4. As you see here, ratios are not equal. So here, instead of this 8, here if it is 4 and here 8, if you interchanges, then you will find this is a Wheatstone bridge, and 6 ohm, there is no current in 6 ohm, that is the part of Wheatstone bridge. But this circuit is different. This is not a Wheatstone bridge. This circuit is not a Wheatstone bridge. So to evaluate the equivalent resistance, you have to go for either that tedious work start this one Kirchhoff's second law, means applying loop law, either or some another way. So here I have introduced a star delta rule. With the help of a star delta rule, we will very easily convert this in series and parallel, and within minutes we will calculate this equivalent resistance. Let's see how. So for the given network, we can easily convert this as a star delta conversion. Let's see how convert. As you know, you see this point. Let this point be A, B, C. As we have already shown, the delta network can be appear in this manner also, like triangles, or like this way. Won't be delta, like it will be become due to this three arms. It seems as delta. So let's see with this point. You just connect this is from this nodal point to this point. That is 4 ohm only. So here, if you draw this line and make it like this 4 ohm, so you will get like this way. So to appear the result as a delta, we have drawn like this way. We have done nothing. This is the same circuit, but only from this point to this point connect this resistance. That is 4 ohm. 6, 8, and 4, and it seems like delta like this way here. Let's see. This is 6, 8, and 4. Now this is delta. You can consider any of this point as A, B, C. You can note down here and convert this in terms of a star. And now that will be appear as a circuit. So here what we see, if you convert this in star network and equate it with this one, so to evaluate this resistance, this resistance, this resistance, then the circuit will become very easy to count down. So let's start. So here to evaluate this result, how to find? To evaluate this result, how to find? Multiply 6 into 4 and then divide with 6 plus 4 plus 8. And here also for this, you have to multiply 6 and 8, and here then divide with 6, 4 and 8. Let's see. As you know, here this one, right? So as RA, RB and RC is there. Let's see, this point be A, B and C. So as AB is here, there is no need to write over here. That's pointer, and from this a star. So here you have to multiply with 6 and 8 and divide with this, and similarly you get all the resistance RB. And here you have to multiply with 8 and 4 to evaluate this resistance. You have to multiply with 8 and 4 and then divide with 8, 6 and 4. Sum of 8, 6 and 4. So that is 1.77 ohm, 2.66 ohm and 1.33 ohm. So in this way, these two resistances are here 1.33 ohm and 2.66 ohm. So this is connected like this way and this way. So from this, it's very easy and it's very clear that here these two resistances are in series and here these two resistances are series. So 8 and 1.33 simply you add it, and 4 and 2.66 you simply add it, and now these two branches are in parallel, so include this in parallel, and the result will be in series with 1.77, and the final result will be also in series with 4 ohm, and in this way you can evaluate the result. Let's see. 1.77 after the correction, this parallel, and this parallel will be 3.88 ohm, and in this way the series and this is parallel. So with the help of a star delta rule, how successfully we are converting the complex circuits in terms of series and parallel order. Let's see some more questions. So here the question is two frightening type of questions. If you see one at a glance, then you will frighten how the circuit goes like this and how the circuit is doing. So without using voltage law, loop law, you are unable to solve this. So better just we will go for the star delta rule here. Let's see how. So think about this. You can pause this video and apply the star delta rule. You will get the how to apply the applications in these all circuits. So after the pausing the video, and if you are unable to solve, then come to the solutions and let's see. Let's analyze the circuit. This is the point here. This is D. Between D and E, that is 4 ohm. Between C and E, that is 8 ohm. One of them, another, that is 7.6 ohm resistance is there. Let's see. And here there is a 1 ohm. And here this one is 3, but here the problem arises that F is connected with this point. So how this works? Let's see. If you see this point and this point and this point and this point, here there are the 3 points. So how these are the converging delta and where the star, you have to recognize this. Let's start the solution. So you see here this converting inner star 3 ohm, 3 ohm and 1 ohm. Where this is 3 ohm, 3 ohm and 1 ohm. You see this one 3 ohm, 3 ohm and 1 ohm. Okay, let's see, this point is G, D and E and this point is F, right? So G, D and E, G, D and E. Now check the solution of this question. As if you see over here that G, D and let's say E. So between this G and F point, F is the nodal point, or you say also neutral point. F may be neutral point. If you stretch here, then you will find that there will be a star. So between G and F, there is 3 ohm. Between F and D, once again 3 ohm. And between F and E, there is 1 ohm. So this star can be converted into delta. So let's see. So GDE point connected with 3, 3 and 1 ohm, convert this star in delta. So like this here, this is G, this is D, this is E, GDE, the same point, and F, which was the neutral point over here. So if you convert it in star, then using this 3 ohm and this 3 and 1, first of all you have to add this to find R1. So look here, this is if R1. So between G and D, if it is R1, then you have to go for this one, 1 ohm in denominator, and this 3 will be in numerators. So 3 plus 3 into 3 upon 1. Similarly, R2, that is between E and D. So between E and D, what are connected? 3 and 1 ohm. So 3 plus 1 and 3 into 1 upon this 3, this 3 is in denominator. Now what about R3? R3, that is between G and E. Between G and E, once again, that is how to find this between G and E. G and D opposite to G and E point, that is 3 ohm. Yeah, this will be in denominator, and 3 into 1 and 3 plus 1. So 3 plus 1, 3 into 1 on 3. Solving this, you will get 3 plus 1, 4 plus 1, that is 5 ohms. Here also 5 ohm, here 15 ohm. And in this way, this star 3, 3 and 1 converts in delta from this C, G, D and E point. Let's see how. So if this circuit converts in like this way, that's okay. Circuit, now this becomes, look at the point here, that was 15, 5 and 5 ohm. This 15, 5 and 5 ohm converts like this, 15, 5 and 5 ohm. So 15, 5 and 5 ohm, when it is converted in this point as GDE, you say, this convert to this 15, 5 and 5 ohm. Okay, so that was the 15 which was converted with 3, this 5 converted with parallel to this, it's associated with this 5 and 4 ohm, and that was where this 3 and 4 ohm, let's see over here. This was the 3 ohm and this was the 3 ohm, this 3 already converted. So this was the 3 ohm, this was the 4 ohm. It's okay. So this is here 4 ohm, this was here 3 ohm. That 4 and 3 ohm is, look at point here. This one is 4 ohm, this one is 3 ohm, this is here. And 15 and 5, this point GD and E. And here that is 5 ohm, another one. So 15, 5 and 5, that was from delta. Now this two are in parallel, and this two are in parallel. Once again, let's see over here, 2.5 and this 20 upon 9, and then 5 ohm. And here 7.6 as it is, and 1 and 8 as it is. Now, if you see, it's once again a type of bridge. So, can you understand that whether it is Wheatstone bridge or some else? Let's see. So, if it is not, then still you have to convert one of the delta into star, like this way. So, 1 ohm, 8 ohm, and 5 ohm. If you see this 1 ohm, 8 ohm, and 5 ohm, this convert this delta into star because it's not a Wheatstone bridge. So 1 ohm, 8 ohm, 5 ohm, if you convert this, you can pause this and check the slides. Now I'm not explaining this one detail, that how to find this delta to star. It's very easy. From here, if you see, then you have to multiply 1 and 8 and then divide with this sum of all three. So 1 into 8 and 1 plus 5 plus 8, that is 14. Similarly here also, you will get 4 by 7, 5 by 14 and 20 by 7. Let's see. So this converts in, once again, that is in star. So that is 4 by 7, 5 by 14 and 2 by 20 by 7. And in this way, this star, when here you will get this one star, then this 5 by 14 and 2.5, now it is in series, and 20 by 7 and 20 by 9, once again it's series, and the resultant is in parallel. So in this way, we say 5 by 14 plus 2.5, this is the series, and 20 by 7 plus 20 by 9, this is in series, and these two equivalents are in parallel. So the equivalent circuits from here, from this point, that we say 4 by 7 included in series, and 7.6 once again it is series, and final answer is 10 ohm. So look how easily we can solve by using the series parallel combination with the help of a star delta rule, which was a very complex circuits. And let's see one more question. As here in this question, it is seems like a Wheatstone bridge, but once again here, due to this point, when the wire is connected, that is the 8 ohm, this disturbs. So when this disturbance occurs, once again you have to rush on the loop law, but loop law is too much cumbersome and it is not easy to handle in a very easy manner with a short span of time. So within this short span of time, better just go for a star delta rule and go ahead. You can once again try yourself, or otherwise you can come jump this video, jump this solution in this video. So let's see. As here you find that is 538, and here also 854, and here uh, no other analogy. So you have to recognize where the star and where is the delta. So look at the point here. So in this position, when let's say this point and this point and this point, this will be as a neutral point. So 3, 5 and 8, which is in a star, if you see here, then we are converting 3, 5, 8 into delta. This star converts in this delta, and in this way we get the values of 9.875. Now you are able to solve this, replacing inner star into delta. You see 15.8 and 2.26.35. So in this way, now the circuits be pretty easy, and 6 4 this 6 4 and 5 and 4, these are as usual in the previous. So if you see over here, as this the star converts in like this one, 9.875, and this one is here, And when you add this two in parallel and this two in parallel, you will get 3.8 and 3.5 ohm. So simply this one and this one, and now it seems like this one, this is in series, but here you have to, the point is here, that is A and B. Once again, there will be here 6 and 9.78, 9.75 and 3.8. This as a star, So here you see converting upper delta into star. Now here you find, if you see over here, then this point, this point, this point, delta. Here in this we are planning to just convert this delta into star as a 6, 4, you know, here that is 6, 4 and 9.875. If you convert this in a star, then you will find 1.2, this is 2.98 and 1.99. And this way you can see over here, this is, and 3.8 and 3.5 is as it is. Now this is in series, this is in series. Here 2.98 and 3.8 is in series, and this is in series. You can add this in simply. So that we say here this 3.8 and 2.98, this is series, and now this is in parallel order, and 1.2, that is in series. So in this way we get the result 4.23. Now let's do one more problem over here. Obtain the equivalent circuit RAB for the circuit and is use it to find the current I. First of all, you have to recognize how many star network and how many delta network. You can say also Y networks. So how many Y networks are there? So if you see here 110, this is N and C. If you consider neutral point, then there will be two Y networks, and you see this one, and this two loops. So you will find here three delta networks. So finally what we conclude, that two Y networks are there and three star networks are there. So consider any of the Y into delta network. So let's see. You can say this, let me consider anyone, either this one or this one, any of the Y networks. 5 is common in both the Y networks, so you can consider this one also. Even 10, 20 and 5, convert this Y into delta, and then we will go for series parallel combination. Let's see. So here, there is two Y networks and three delta networks, as you see over here. So I'm going to convert here this Y network 5, 10 and 20 into delta. So if you convert this delta, that this point ACB, at this ACB point, what you will find, 5, 10 and 20. So 20, that is, if you can come to the point, this one B, then here A and C, that is the common point over here. So R1, that is 5 plus 10, 5 plus 10 upon, means 5 into 10 upon 20, that is 7.5. And here you find 12 point, which will be parallel to 12.5 ohm. This will be the R1. And if you see R2, then R2, that is here, it means it will be now parallel to 15 ohm. Then you see 5 into 20 upon 10, and then besides 5 plus 20 also. So that is 35 ohm parallel to 15. And similarly, if you consider 10 in 20, so 10 into 20 upon 5 and plus 10 plus 20, that is 70 ohm, which is parallel to 30 ohm. So in this case, you will find 30 is parallel to 70, that is 21 ohm, and 12.5, which was parallel with 17.5, that was 7.92 ohm, and this. So now look how easily this circuit reduces in this format. So what do you find here? Now this 7.92 and 10.5, which is the equivalent of this two parallel series, and here it will become in series order, right? So this converts in series, and when you add this with parallel 21 ohm, you will find 9.632 ohm. In this way, we can find the current through A and B. As voltage was 120, it was given over there, and resistance 9.632 equivalent, and solving we will find 12.458 ampere current is there. Let's take one more question, and I will give you some more problems for practice to you also. So let's see about this one. Determine the load current in branch EF. As EF, this one EF 600 ohm is connected over here in this circuit shown. Now once again, here the star delta provision is there. So this delta you see, and here there is a star. So now this is a wise approach when star converts in delta and delta to star. Try yourself first and then go to the solutions. Okay, so after attempts, a lot of attempts, if you are unable to solve, then you can come to the video and let's see. So what I'm doing over here as A, C, G and this one A forms delta. Now converting it into equivalent star, that is n with a neutral point over here. So there is 200, 200 and 500 ohm. And in this way, we can convert this as, look at point here, this 200, 200 and this one. So this converts in AN, means this is A, this is G here, so GN and CN, and with the neutral point over here for this delta. If this delta is converts in a star, so what you have to do, from the A point, 200 into 500 upon 2 plus 5, that is 900, and similarly here also 500 into 200. In this way you will get 111.11, and here also 44.44. So these points are there. Now this point at this point is equivalent over here, that is 200 ohm, right? And here also that is 200 ohm, and here that was 500, which was converted already in delta. Now if you see this, so circuit can be redrawn like this way. Okay, 500, 200 and like this, and this is a branches series order in 600. Now here you will get this all and this, and so finally what we conclude over here, that is this entire results is, as in, you see branches NCD and NEF are parallel. NEF are in parallel. So you convert this in series and then the result will be parallel to this two series branch. And hence this two series 111.11 and now 100 volt is in connected with this circuit. So in this way you can get that current 0.22 ampere. Now let's find, to obtain the current in branch EF, we apply current division formula. Current division formula, you all know, it goes in reciprocal to the ratio of the resistance. So current division in EF branch, is given by I into R of NCD upon R of NCD plus R of NCD plus R of NEF. So in this way, you can find this current also. So let's take some more problem for practice to yourself. A square and its diagonal are made in a uniform covered wire. The resistance of each side is 1 ohm. Fine. That each of the diagonal is 1.414 ohm. Determine the resistance between two opposite corners of the square. Here also a star delta comprises. Now go for another question. Find the current in 10 ohm resistance in the network shown in star delta transformation. 180 volt is there, and you have to find the current in 10 ohm. How many delta network will be there? You have to go ahead and then try. You just put the solutions in the video, give the answers. If you find any difficulty, you write. I'll give the solutions in the next coming video also. So look at this one more problem using a star delta transformation. These all are practice. You can do very easily. Here you have to find the maximum power consumed in 4 ohm resistor. Look at this is the 4 ohm resistor. Here you have to find. Now safely go ahead. Here there is a star Y network. Here there is a delta. It's okay. So you have to make a wise approach how delta convert to Y or Y convert to delta. You have to make your decision. Very easy. Here once again Y network, delta network is there. Determine the resistance between terminals A and B of the network. Only star delta network you have to use. Conversion of star to delta or either delta to star, and you will able to solve the equivalent resistance between A and B. Okay, thanks for watching.